All right, let's look at using Simulink to analyze a sort of a simple circuit. So here's one where I have an RC circuit, okay, similar to what you have in your homework. All right, now in this particular case, when we give you a file, what you need to do is to put that file in your home directory, and then you just type the name of the file in the command line, hit enter, and it'll open up. So in this case, the file is rcfilter.slx. Now what I can see is I've got a couple of components here. I have a voltage source. I've got a resistor, capacitor, and ground. That's my whole loop. Then in addition to that, I've got some measurement stuff, right? So basically what I have is a device that will measure the input voltage. So I've connected that across the input source. So notice that there's a plus input and a minus input, and I have to connect them both to be able to use this. And then I have this output voltage measurement with the plus terminal connected to the plus terminal of the capacitor and the minus terminal connected to ground, which is the same as the minus terminal of the capacitor. The outputs of both of those measurement devices are connected to this oscilloscope over here. All right, now if I want to know the values of the components or change the values of the components, what I do is I hover over them and I double click, and I can change the resistance in ohms. Okay. If I look at this guy, double click on him, I can change both the value of the capacitor. So in this case, it's 1 microfarad. And I can also change the initial value of the voltage. For now, I have it at 0. Okay. All right, so what I want to do is just kind of play around with this circuit a little bit, just to see if we can understand how to use the analysis. Before I do that, I guess one thing I want to look at real quick is this voltage source. So basically what controls this voltage source is this thing right here, this sine function. Okay. So if I double click on that, so I see that I can set the amplitude. So that's 4 in this case. Bias is something we're not going to talk about right now. Okay. Frequency. So in this case, I've set it to 2 pi times 1,000 radians per second. So that would be 1,000 hertz. And I've given this guy a phase shift of 90 degrees. Notice that I've multiplied that by pi over 180 to get that into radians. Okay, so by definition, this thing is a sine wave and not a cosine wave. And I've shifted it by 90 degrees, which ultimately makes it a cosine wave. Okay, so what I'm going to do is to be able to utilize this particular thing, I got a couple of things up here at the top that I need to understand. So up here is my simulation stop time. So right now that's set to 0.1 seconds. So that means that when I run this, it's going to run for 0.1 seconds. And then I've got my play button up here, which will run the simulation. So let's run this. Okay, so he's done. Should be over pretty quickly. Okay. And he ran for 0.1 seconds. So if I want to see the results of that simulation, I go over to this oscilloscope here, and I double click on that, and he should open. Okay, and I'm going to move that and full screen that. Now what I've got is both the waveforms. So the top is the input voltage. So just to be clear, the input voltage is the voltage across the capacitor. Sorry, the input voltage is this voltage source here. The output voltage is the voltage across the capacitor. So the output voltage is the bottom wave here. The input voltage is the top wave. So if I click this thing right here, where it has the, first of all, let me just be clear. There's a couple of choices here. It basically makes the waveform full screen. So I've got a couple of choices. It says scale X and Y axes limits. So I can scale the X and the Y. I want to scale them both. What that does is it makes both the waveforms sort of fill up the screen, makes them a little bit easier to see. If you look at this, the voltage across that capacitor is 0.04 volts amplitude, whereas the voltage across the input source is 4 volts. Okay, so it's significantly bigger. So let me make that full screen. And what I want to do is I want to make some measurements on that waveform. So I'm going to use the cursor. Alright, so now to use the cursor, I want to make sure the zoom function is off. Okay, and now I can use the cursors and I can move them around. Okay, And I can change which waveform the cursor is applied to over here where it says trace selection. So right now it's on the input voltage, but I can change it to the output voltage, and that moved. So notice this dot moved from here, moved from the top to the bottom. So if I go to input voltage, now I see the dots here applied to the input voltage on the top. And if I change this to the output voltage, the dots here move to the bottom. So now I'm making measurements on the bottom waveform. So let's say I want to zoom in real quick to the beginning. So I click on the magnifying glass, and I can zoom in at the beginning of the waveform. So one thing you can clearly see is I have a cosine because this waveform starts at its peak and then varies real quick. Let's say I wanted to measure the period. So if I wanted to do that, I'll go to the input voltage, make sure the magnifying glass is off. Now, I see the cursors here that I use to make my measurements are off the screen. So notice what I did was I moved my mouse up to where it said the number 1 and the number 2, and that allowed me to pull those along. Once they appear, what I do is I put my cursor over top of that line, and I pull. Basically what I'm doing is I'm holding down the left mouse button and pulling to the left as I do this. Alright, I'm going to pull this guy. I'll set him to right here, right at the peak of that waveform. As best I can get it to the peak at least. Okay. And I see that I got it pretty close to the peak. It says the peak value here. So the number 1 and 2, it tells me right now that my cursor is located at time 9.964 times 10 to the minus 4, and the value that it's getting there is 3.995 volts. Okay, so now I'm going to move this guy over. So notice the numbers for number 2 here. The time and the value for number 2 are moving as I move this guy. Again, I'm holding the left mouse button and I'm dragging my mouse to the left. Set that to the peak value there. Okay, and I see that the delta t is 1.004 milliseconds. So if I want to figure out what the frequency is, let's pull this guy up, the command window. So it says that my delta t, so notice over here it says my delta t is 1.004 milliseconds. I put e to the minus 3. So my period f is 1 over delta t. So it says that's 996 hertz. And if you look at what it actually was in the circuit, it was actually 1,000 hertz. So just to be clear, I measured 996. Just how much of a percent error is that? So 1,000 minus 996 divided by 1,000. So pretty small. I'll multiply that by 100, I guess, to get to a percent error. Sorry, I did my math wrong there. 1,000 minus 996 divided by 1,000. Multiply that by 100. That's a 0.4% error. All right, that's a pretty small error that I just had from my measurement. All right, now let's say what I wanted to do is I wanted to figure out the time between these waveforms. So what I'm going to do is I'm going to zoom out a little bit. Now I'm going to choose my magnifying glass, and I am going to zoom in somewhere out here where I know I'm truly in steady state. And what I'm going to do is I want to measure the time delay or the phase delay between those two waveforms. So in this case, oops, go back to my magnifying glass. Okay. Now I want to use the cursors again, so I turn off the magnifying glass. So I basically left clicked on it. And then I'm gonna left click on number 2 and drag him over here, and I'm gonna bring him into the screen. I'm gonna do the same with number 1. All right, so if I want to measure the delay between the two waveforms, all right, what I do is, because I know the input was a cosine, I'm basically gonna line up to the peak of the input. All right, so I'm pretty much at a peak right there. And then I'm going to move to the output voltage, and I'm going to move number 2 to the peak of the output voltage. The peak of the output voltage is down here, right? So I'm going to move that along to basically at the peak. So number 1 is aligned here with the peak of the input. Number 2 is aligned with the peak of the output. So the delta t, the time difference between line 1 and line 2 here, is 244.287 microseconds. So I'm going to move this guy to the side. So the time difference there is 244.287 microseconds. So I say times 2e to the minus 6. And that's the time difference. So just to understand here, so if I want to get a phase difference, okay, so a phase difference, essentially what I need to do is I need to convert that time difference, delta t, okay, to how much of an angle it represents in this signal. So that delta t we said was 244, what was it, 244.287 microseconds, 0.287 times 10 to the minus 6 seconds. So if I want to convert that to an angle, phi, that would be 2 pi f times delta t. Okay, so in this case that's 2 pi times 1,000 times that delta t. Okay, so that will be 244.287 times 10 to the minus 6 times 2 times pi times 1,000, 1.5349. Now because sine here is defined in radians, this is 1.5349 radians. But I want to convert that to degrees. So I say 180 over pi, like that. So I take that and I multiply by 180 over pi, and I see that that's basically 87.9433 degrees. Okay? So sort of a simple way to be able to get some measurements here. One thing I might want to ask myself, we already kind of said this, but what's the amplitude of the output? Looks like the amplitude from looking at this is about, and I can take the number here from the cursors, but it looks like it's about 0.04 volts. So I can say that the amplitude V out is 0.04 volts. Okay? All right, so the MATLAB stuff is relatively easy to play with, or the Simulink file is. If I wanted to run this thing for longer, right, I wanted to see more values, I could change this time up here. Let's say I wanted to run it for 1 second. Change that to 1. Hit the play button. All right, and now I go to my oscilloscope, and I can see this guy looks like a big blur, but I see he's run from the bottom 0 all the way to 1 second. If I wanted to zoom in, I can. All right, and I can zoom in even further if I want to. And notice that didn't really change anything about my output. Okay, so it's relatively simple to use the files that you guys have right now.